All those who joined us today. Good afternoon. My name is Najia Zaman. I work as a student presenter here at the museum, and joining me on the call today is my colleague Nick Van Ecker, a fellow educator here at the museum. If you'd like to say hi, Nick.
Hey everyone, my name is Nick Van Ecker. I'm also an educator at the museum. I'm going to be moderating the chat today, so if you guys have any questions, you can feel free to leave those in the chat box. I think Najee will also be asking you some questions. You can feel free to answer in the chat box as well.
Yep, sounds great. And in today's show, we'll be talking all about food. And before we begin, for those new to what Science on a Sphere is, SOS is a program developed by NOAA, the National Oceanic and Atmospheric Administration. And through this program, the images that you'll see being projected onto this sphere is through 4 different projectors that surround this big gray ball made out of fiberglass that hangs from the ceiling. And through this sphere, we can explore big planetary data sets that allows us to talk about topics within science and culture and dive deeper into them. So Earth is an interesting place, full of so much diversity and richness of life, in part shaped by the environments that we have, that we can find on Earth. We have the hot deserts, the lush rainforests, the dry tundras, and they're all different types of environments that life on Earth has uniquely adapted to. And these biomes have not only shaped the biology that we can find within them, they've also shaped us. And so I'm going to pull up a data set that shows all the different types of climates that you can find on the Earth. And even though this map is pretty colorful, it's divided into 5 general categories based around the amount of rainfall received, typical temperatures, and also vegetation. Basically, the areas with the same colors should look and feel the same to us. And so growing up in a very mild environment like Michigan, I've always wondered how people survived in extreme environments like deserts. And feel free to drop it in the chat real quick. But one question I had is if you can guess what the red parts might be, what sort of climate you might find there, and then also the blue parts, which is pretty centered around, Brazil and the Amazon. These 2 might be really easy to guess, but yeah, feel free to drop it in the chat. So when we're talking about the deserts, everything from their clothing to the shelter to the food and water that they obtained was adapted to survival. And the need to find food and water in these extreme environments led many desert communities to become nomadic. So Nick, if you're ready, you can pull up the slideshow. Yeah. And so another question I had is, what does it mean to be nomadic? And you can also put that in the chat if you have an idea of what it means. But basically, it means that you don't have a permanent settlement. You're pretty much moving around. It can either be moving around for most of the year, or you can also be semi-nomadic where you're moving around for parts of the year. But basically it means that you don't have a permanent settlement. And in the dry deserts of the Middle East and Asia, nomadic tent communities still exist. These tents are specifically made so that they can be transported on all sorts of pack animals like horses, camels, or donkeys. And they move frequently so that the flocks that they're herding have access to pasture land for their food, and also water. And so on the next slide, we have a few photos of the Mongolian steppe, and also the tent structure that I just mentioned. And if you notice, it's described as it's described. It's pretty light, easy to move around, and easy to dismantle as well. And on the next slide, I have a picture or a couple pictures of different foods that you might find. In the lower left-hand corner, there are photos of different cheese products or dairy products that you'll find. And the Mongolians developed lots of different fermentation techniques and also drying techniques in order to preserve the food that their animals provided for them. And on that upper right-hand corner, I have a photo of a specific dish made out of mutton or sheep, which is a really integral part of their diet because it's one of the animals that they typically herd. And in this dish, they basically take most of the parts of the sheep, boil them together, and then pile it high onto a plate for an entire family to eat. Moving to the Bedouins of the Middle East, as you can see, they have the similar tent idea, very easy to put apart and carry around, and actually traditional ones were made out of goat hair. And on the lower corner, you can tell that the environment is very hot, dry, and dusty, and so accordingly their clothing is specifically, like, its purpose is to protect them from all sorts of winds, sands, and also the sun. And as for some of the foods that they eat, lots of rice is used, and also lots of different breads were developed in this region because rice and flour are really easy staples to carry around and are pretty lightweight as well. And on the other side, on that other left-hand side, I have a photo of dried fruits, which are very popular in that region, and also some teas. And then before moving on, we wanted to highlight one more community, the Sami, who are semi-nomadic, and they also herd animals, but not sheep or goats like the Mongolians or Bedouins. And these people live actually all the way up in the Arctic North, near that area where there are the dry tundras and the taiga forests. And if you can guess what the animal is in that lower left-hand photo, feel free to put it in the chat. But the animals there are actually reindeers. And accordingly, reindeer is a big part of their diet, and other staples include fish and meats that they can hunt from the environment, as well as fruits that they can forage from the forests. And if you can think of some similarities between these groups, feel free to drop that in the chat below. But the basic idea here is that even though these groups are distributed in wide geographic areas around the world, they still have similar ideas in terms of how they prefer to store food, the types of shelters that they prefer. And also their food looks really different from how we eat in the cities and even agricultural communities. And so when we think about some things or some resources that it takes to grow food, some things that might come to your mind are things like land, and specifically fertile soil, or just generally good quality soil, but also water. And despite much of the Earth's surface being covered by water, we can actually drink only less than 1% of it if we're thinking about the available fresh water that's pretty easy to get. So water is definitely a limited resource when it comes to agriculture. So Nick will go ahead and play another short SOS movie, and we'll take a look at how our demands for water have shaped the earth so far. I think you might have to share your sound.
Water is our most precious natural resource, one for which there is no substitute. Water is vital for all life. Earth has the same water it had 4 billion years ago, recycled countless times through the hydrologic cycle. While the total amount of water has remained the same, the distribution between saltwater and freshwater and the partitioning of freshwater among liquid, solid, and vapor phases has varied over time. What has changed dramatically is the demand for water. Human population and our demands for water have exploded. The population is now more than 7 billion and is projected to reach 10 billion before leveling off near the end of this century. More than half of the world already lives in water-stressed areas, and the United Nations predicts that it will increase to 2/3 by 2025. Groundwater, long thought to be the safety valve, is now the world's most extracted natural resource. It can take decades, centuries, or even longer to be replenished. One of the big challenges is that often water is not where the people are. Around the world, humans have engineered complex plumbing systems to move water from where it is to where we want it. More than 60% of the world's largest rivers have been dammed or diverted, and more dams are being built. Dams have the capacity to disrupt the flow of water, sediment, and nutrients to countries downstream, with the potential for devastating consequences. Another major challenge is that more than 90% of the world's population live in countries that share water bodies with other nations: rivers, lakes, and groundwater. Multinational river basins include many of the world's great rivers: the Amazon, Congo, Danube, Ganges, Mekong, Nile, Rhine, and Tigris, as well as the Columbia and Colorado rivers. In most of the world, there are no agreements that specify how these waters are to be shared. Many are in regions of political unrest: North Africa, the Horn of Africa, the Arabian Peninsula, and Southwest, Central, and South Asia. The aggregate population of these countries is expected to triple by 2100.
Yeah, so that video kind of went into some of the stressors that we currently are having on our global water supply. But one really interesting statistic in there was that 60% of the world's rivers are now dammed up. And if we were to continue the video, another statistic that they would have mentioned is that agriculture accounts for about 70% of our total water usage. So what are we doing with these crazy amounts of water? Well, the map behind me is showing the distribution of cropland across the world, and basically all the places that we're using to grow food. Now, the thing is, sometimes all this food is being grown for human consumption, but sometimes it's grown for animal consumption, and we call that type of production feed. So if I were to tell you that the red and the orange regions kind of signify what we're growing for livestock, and the green or yellow regions are describing what we grow for human consumption, feel free to drop in some trends that you might notice. And I'll just let it rotate for a little bit. Might be a little bit rough to see, but because the colors got a little bit washed out, but you might be noticing that certain parts of the world are growing a lot more for human use versus other regions of the world growing a lot more for animal use. And mostly the animal use is in the West, while in sub-Saharan Africa and in Asia, you'll see a lot more stuff being grown for human consumption. And this actually isn't even beginning to take into account all the land that we're using as pasture land, or basically the land that we're using for grazing animals like cattle or sheep. And so another challenge we're facing with water is the difficulty of supplying enough of it to our large and ever expanding cities. Just like it is with water, getting enough food there is also a big challenge. So how does food get into our cities? Well, there's a number of ways that food travels around the world, each with its own carbon footprint. Sometimes food is flown from place to place through airplanes, or it can travel across the ocean in these really large cargo ships. But we'll go ahead and talk about the two major ways food travels on land first. And that is through railroads and just your general roads or through trucks. So I'm gonna pull up all the railroads in the world, and you'll start to see that some areas have really developed rail systems, while other areas are kind of working on it. Some areas have a crazy amount of railroads developed, like in the Europe and the US. And now I'm gonna put up the roads all around the world, and that's gonna be in black. And you'll start to see the map looks a lot more crowded. So most of the area, or most of the world's lands have been developed through railroad systems or road systems. And it's crazy to think just how much we've built on this land throughout the world. But speaking of food being a global project, one of the other routes I mentioned was shipping. And this data set shows all the shipping, all the commercial shipping routes and the critical straits that they travel through. So all the continents are in black, as you might have noticed, while the shipping routes are in red. But they're truly all over the place. And there's quite a bit of activity across the Atlantic and across the Pacific. Yeah. So out of the 4 ways that food is moved around the world, Can you guess which one might be the most energy efficient? So the 4 ways, and Nick, if you could put it in the chat, is cargo shipping, airplanes, trucks, or railroads. And maybe I'll give it like another couple seconds. But actually the most energy efficient way to move food around the world is cargo shipping, followed by trains, then trucks, and lastly airplanes. And this is because of the sheer volume of stuff that can be moved at once in these really large cargo ships. And this is that when we're talking about energy efficient, we're talking about like the amount of CO2 transmitted in order to move that food item from one place to another. The problem is shipping is a major ocean polluter. And all of these methods are powered by fossil fuels, which contributes to global climate change. So far, we've explored how human activity through agriculture has been shaping the world, and now we'll transition a little bit to what does that look like in the future. So this is another version of the climate map that we saw earlier, except this time it's now mapping global changes. And I'll just let it play for a second. There we go. And it's actually mapping changes from the year 900 to the year 2100. So it takes the data that we've collected on all these different climates from the year 2007. And then after 2007, it turns into a projection of how the world is going to be changing using an internationally researched climate change scenario. And as we continue through the data set, you might be noticing that certain areas are moving up and across, especially around Russia. Or that just generally, there are lots of climates that are shifting around as well. And all by the year 2100. And maybe you know the stories of the melting ice caps and how it's critically endangered polar bears as a result. If these changes were to happen, like as we're seeing them on the sphere, we would also be facing massive changes to the way that we survive. Though we don't know completely how climate change will progress, these models help give us an idea of what the future might look like and some things to prepare for. So let's further explore the connections between climate change and food production. So there's really no end to the number of ways that food production will need to change, but one of the ways that scientists are really examining right now is how we distribute resources, specifically really important ones like water and also fertilizer, which are both finite. So this map is actually showing cropland production for 3 of the world's major crops, which are corn, wheat, and rice. And where the yellow is, it's basically telling us that these areas could produce more food, but they aren't right now. And the black areas tell us that they're pretty much producing what they could produce at maximum. And so actually one of those regions is for example, the Midwest. The Midwest is pretty much producing as much as it could possibly produce, while if we flip the globe around a little bit, you'll see a lot more yellow in India and also Eastern Europe. And those are signifying places where resources like water and fertilizer distribution could be improved to increase the yield. And this helps farmers and policymakers avoid wasting more land than necessary, like cutting away the forest, for example, for extra cropland, and really helps us focus on what we already have and make the best out of what we already have available to us. And this map is pretty interesting. We haven't talked too much about the ocean yet, so we're going to focus on that for a quick second, because it's a vital source of food for many people. And this map from 2009 is showing the global distribution of about 1,000 commercially harvested marine fish and invertebrate species. In areas on the map that are very brightly, yellow, it looks like. On the map behind me, they're sort of more orange, but on the screen, the bright yellow areas are very diverse marine areas for fisheries, for example. And while the cooler purple areas indicate the less diverse areas where people fish. And that triangle that I paused on is actually a really important area. You can see that there's lots of different yellow areas here off the coast of Vietnam and also around Indonesia and Australia. That triangle is actually called the Coral Triangle. And it's pretty special because it's one of the most productive fishing areas in the world. And as a result, many nations now depend heavily on their fisheries for their livelihood and economy. And for some of the countries in this region, fish or other marine species provide over 90% of the protein source in their diets. And as I unpause this map and we let it rotate for a second, you might be noticing that there is a lot more diversity outlining the coasts pretty much. And these coastal areas are where we find our largest marine ecosystems like coral reefs, mangroves, and marshes, which provide food and shelter for many economically, culturally, and ecologically important species. And this map really helps us see how important it is to protect our coasts and practice sustainable fishing as well, both for preserving the marine life and the fisheries that so many people depend on. And so how does climate change affect marine life? What exactly is there to protect? One of the major situations right now is how the ocean is acidifying. So how does that work? As CO2 builds up in our atmosphere, much like how our bodies have different mechanisms that kick in when one part of the system is stressed, the Earth has a similar mechanism. So the rest of the Earth tries to compensate by soaking up this CO2. And in the oceans, the CO2 is absorbed and reacts what's already within the water to create this acid that then acidifies the ocean and lowers the pH of the ocean. So as the map turns into this, so it's starting off a pretty dark blue, and I'll cycle back again. But starting from the 1800s, it's a really dark blue, and the normal pH of the ocean is around 8.2, 8.3. And then as the years progress, we're seeing that most of the world's oceans are starting to acidify and turning into this light blue color. And at some point, this turns into a projection and goes all the way up until the year 2100. Basically, if current trends continue, we'll see that a lot of the world's oceans have a pH closer to around 7.7, which is not good because the ocean is meant to be a bit more basic. And marine life has adapted to this pH and depends on this really delicate balance. So the fact that our oceans are acidifying is not good news for those species and also those of us that live in these coastal communities. But given all this information though, what is there to do? Urban farming is an idea that has been catching on these past few years as people are looking for ways to reduce their carbon footprint and grow as much of their own food and produce as possible. Another framework to think about is permaculture, when we're talking about reforming different pretty wasteful agricultural practices, where permaculture is a philosophy of building human activity and in harmony with the Earth's natural systems of regeneration. Earth has shaped humans for thousands of years. It shows in the ways that we dress, the ways that we see the world, where we end up living, and fundamentally what we eat. The title of today's show is Eating the Earth. And as we advance into the 21st century, we now have to think about what agricultural footprints we'll be leaving on the earth for generations to come. Thank you so much for joining us today at the museum for today's show. We hope that you enjoyed it, and we'll leave the webinar open for any questions or comments that you all might have. But otherwise, we hope that you enjoyed it and have a great rest of your day. Yeah, you're welcome, Julie.